Hi, this is Tim Hegarty with the Virtual Training Company and C++ Fundamentals. We're finishing up our talk here on exception handling with the concept of stack unwinding. Remember, I asked you what would happen if you were in a try block and a try block made a function call, and maybe that function that it gets called into creates some class objects and their constructors get called, and then we do some other work and call another function, and then we throw down in the middle. Well, that throw is going to cause us to have to undo all of the work that has occurred before the throw. We have to go through all of the destructors for all of the objects that were created in reverse order, just the way we do when we're exiting the program. So we have to release all that memory, run all those destructors, and then find our way to the catch blocks and see if we can get a catch block that will fit our throw. If there is not a catch block to fit, we will call a function called unexpected. Unexpected simply does an abort, which dumps off the rest of the code and exit out of the rest of the program. There's also a terminate. There's a terminate function that can be called if we try to catch an exception that we have not taken care of. We have not set up a catch for the particular kind of exception, so we can go and do a terminate. So let me show you some code here. Code's always simpler to talk about. So here we have this is a new structure, and it has a message in it, and it has a constructor that will build this message. So E can be used with a message in it, and that's what we're going to be throwing, is our error structure. Now here's a new function called myTerminate. We want to replace the terminate function that's in as part of the runtime, so that we can see something happen. And we will replace that with a little output called a myTerminate that were there. Here's a simple structure A with a constructor and a destructor, and here's a structure B with a constructor and a destructor. Now notice here the destructor of A, while it's saying I'm here in destructor of A, it then throws another exception. So we get another exception while we are trying to get out of the original throw. That will cause the terminate to run. All right, so that's an exception thrown in the destructor. Now we're going to see some very odd behavior, which you've certainly seen from programs before, but now you're going to know a little bit of what goes on. Here's our main function, and we have try, and we're going to call setTerminate. SetTerminate tells the runtime to use this function, myTerminate, as its termination function, so that should the runtime have to call myTerminate, or has to call the built-in terminate, it will in fact call myTerminate. So we set that up first. Then we say that we're in our try block, and we build A and B of our structs. It's really just classes, A and B, and then we will throw an exception. So an exception is thrown in the try block of main, and that's our pointer. That's a character pointer, so that's going to match. Now, when that throw occurs, we have to undo B, and then we have to undo A. We have to destruct them. So we will go up into the destructor of B, and then, because it's in reverse order, then we'll go into the destructor of A, and we will throw another exception. And that's when everything's going to break loose, and you're going to see what happens. We're going to call the myTerminate, but also Windows is not going to like it. Here's our catches. We can catch our constant character pointer, and that is our normal exception handler. Here is everything else, some other exception, and here is resuming execution of main after the catch blocks. So let's run this and see what happens. See, we were in the try block, and we got into the constructor of A, we got into the constructor of B, then we were supposed to undo everything. We did a throw. So we had to hit the destructor of B, and then we got into the destructor of A, and at that point we did another throw, and that second throw did a call to myTerminate. Well, myTerminate worked, but it also calls into the operating system and tells it that we have requested to terminate in an unusual way. Windows does not let this go easily. So we can ignore this termination, and we will still get our little press any key to continue. So this information comes on through that the application has requested to terminate in an unusual way. All right, that's the kind of thing that happens. You can set your own termination, but you have to be very aware in stack unwinding of the terminate function and the unexpected. The unexpected function is done the same way, set unexpected and then some function name if you don't want the compiler's unexpected to be called. And unexpected, again, is only used if you don't have a catch like this with the ellipsis, because that's catch everything, and of course unexpected would not be called because you expected everything by including this. If you didn't use this catch with the ellipsis in it and you only had specific catches, if you if you threw something unexpected, there you go. You're going to call the unexpected function. And in the normal C++ runtime, unexpected just aborts the program. It throws away everything else and closes up shop and leaves. That means files are hanging open and whatever else was going on. So it's not a clean way out. You want to at least try to have this catch ellipsis if you're going to be using try, catch, and throw blocks. You want to have this one so that you can try to catch everything else and not wind up into that weird condition we had with the unexpected. And also in the termination. And remember, you get to terminate if a destructor does a throw, if it has a problem while it's destructing. It's entirely possible, but you want to try to code your way around so that you do not try to throw an exception while you're getting out of an exception.